the original Industrial Revolution was driven by the discovery that you could use steam engines to do all kinds of interesting things.
But that was followed by additional revolutions for electricity and computers and communications technology. We're now in the early stages of the fourth industrial revolution, which is bringing together digital, physical, and biological systems.
One of the features of this fourth industrial revolution is that it doesn't change what we are doing, but it changes us.
3D or three-dimensional printing is considered a disruptive technology that has become so widespread it's making other technologies obsolete. Instead of using ink like a laser jet, 3D printers use powder that is slowly built into an image using 3D CAD software. An ultraviolet laser hardens the powder as it layers to form an image. These images can be as simple as creating a vase or as complex as creating models to facilitate mandibular reconstruction and cranioplasties. In 1904, the Westinghouse Company employed about 3,000 employees who worked in sweltering conditions to pour molten metal into casts to make air brakes. The employees worked 9-hour days and 55-hour weeks to supply the nation's freight system. From the casting to the conveyor, workers would remove the completed iron parts and dump them onto the shop floors. This was certainly before the days of OSHA and personal protective equipment. The workplace hazards were great as workers were exposed to a variety of hazards in these environments, including electromagnetic radiation, burns, and ultraviolet rays, resulting in eye damage and cataracts. And while that was 1904, and with modern advances in personal protective equipment and safety, working conditions are better, they're still not safe because, as you can see in this example, the molten metals can reach temperatures upwards of 1,000 degrees, still creating significant workplace hazards for employees. With the passage of time, so comes the updates in technology. And here we now see brake parts that were once done in those sweltering sweatshops now being produced by 3D printers. Now let's take a sneak peek inside Bugatti as they test titanium brakes made with 3D printers. Now, of course, with all new technology, there's risks, so there has to be rigorous testing. And here you see Bugatti testing these disc brakes in speeds over 350 miles per hour to ensure that these 3D printed materials can stand up to traditional manufactured materials. Now let's look at 3D technology in medicine.
Donors are difficult to find, and what we want to see is trying to be less dependent on organ donations. So with 3D printing, the capabilities to be able to generate organs which are acceptable to the recipient are much larger. But we're not there yet. We are moving towards that direction. 3D printing in healthcare could be defined with two different applications. One is from the model's perspective, basically models that you can literally print into a particular shape and then adjust to the patient. We have certain examples where we see that already starting. So the dental industry sees the printing of crowns and invisible type of braces that could be printed for the customer in the office. And the reason why this is a method that is fairly economical, especially for the patient, is that you do a scanning of the impressions of the patient and then are able to modify in an electronic file what you would like those final state of the teeth to be. And then you're able to replicate multiples of them in one platform. And then there are less visits to the dentist. In using 3D printing for prosthetics, they help from the perspective of being customized and fitted to the stump where the former limb was located, and they're made out of off-the-shelf polymers, so they're not too expensive. From that perspective, it's also cost minimizing in comparison to traditional prosthetics. For example, in the use in pediatrics, the patients are in constant growth, and the cost associated with that fitting would be lower. It also will be a rapid turnaround in comparison with traditional fitting of prosthetics. The second application is bioprinting. The tissue engineering market in relation to 3D printing or bioprinting is expected to have approximately 32% growth in the next few years. The main difference associated with a bioprinting operation and a 3D printing operation is the use of bioink, which is artificial or it could be natural materials, and the mixture of those with cells. And when we say artificial, think about polymers, plastics, and natural could be lactic acid proteins. From the perspective of drug testing, bioprinting could offer flexibility in terms of cost efficiency. And what I mean by cost efficiency is animal testing. Animal testing is fairly costly and does not replicate what the interactions of the drugs will be with the human. So having a platform with 3D printing where we're able to replicate what the human tissue would be, provide us, one, repeatability for the drug testing, two, lesser costs associated with the drug testing. A lot of studies start with mice or rats, but then to be able to prove that it's truly efficient, you have to go with larger animals, and you have to take care of them during the process of drug testing, and it's costly. And with bioprinting, it does provide you a platform to be able to do drug testing without the use of animals.
Here we see a three-dimensional image that's been created so that orthopedists can determine the etiology of spinal fractures.
Hi, everybody. This is Dr. Michelle, and I welcome you to another episode of Tab Talks. And I have my tech guru back with us today, Tyler Smart. How are you doing, Tyler?
I'm doing very well.
Good. May the force be with you out there on the West Coast.
Yes. Yes. Thank
Weather
you.
good out there?
Yeah, it's nice.
Nice. Okay.
Not too hot, not too cold. It's pretty nice.
Okay. Well, today we're going to be talking about 3D printing, and you're an expert. I figure if you can build your own 3D printer, so I thought you'd be the guy to talk to.
Yeah,
So,
I've been doing it for a while, so.
okay, well, wonderful. Let's just kind of start off with the basics. I guess the most obvious question is, what is 3D printing?
So normally when you're building something, you carve stuff away. Like if you have a chunk of wood, you carve pieces out of it to make like a little toy, right? But 3D printing is different because you are taking a material and you are adding it to itself. You are adding pieces until it makes a big thing. So like if you imagine you have a toothpaste tube and then you squeeze out a circle in toothpaste, right? Then you've got a circle out of toothpaste. Then you squeeze out another circle on top of that one, and then another one, and then another one, and you keep going up. And soon you have a cylinder, a thin cylinder of toothpaste. And that's how 3D printers work, except instead of toothpaste, they use plastic.
Wow. Okay, and we're going to talk about plastic. So what was the catalyst for this kind of technology?
The catalyst was Invisalign braces. I think back in the 90s, there were these things called Invisaligns that came out. So
Yeah.
instead of having metal braces on, they would just use 3D printers to make copies of your teeth that would kind of push your teeth into the right location. And so that is the first application that I know of 3D printers.
Wow. everybody, and everybody's heard of Invisalign. So
Mhm.
that was the first application.
That I
Okay,
know
just
of.
okay. Now you were gracious enough. I'm going to put up a video of actually what a 3D printer is actually doing. So can you describe for us in this video that I'm playing, what is this printer doing?
Okay, so this is a really, really fast video of a 3D printer. This is about 10 times faster than it would normally be. This is what's called a Delta 3D printer. And what it's doing is it's squirting out plastic onto a bed, a 3D printer bed. And you'll see it's building it up layer by layer, just like I said with the toothpaste and the cylinder, except it's squirting out the toothpaste is actually plastic, and it's doing it in a different shape, in the shape of a lizard rather than a cylinder.
Wow. So you built a 3D printer.
Yes.
So can we show the audience a photo of your creation and how long it took you?
Yeah. Yeah, absolutely.
Nice.
I sent you that photo. It took me about 40 hours to build, and it took a little less than that to get it dialed in to working to where I wanted it to be. It was a lot of hard work, a lot of muscle. I sweat a lot for days doing that.
What made you want to even undertake that task to build a printer?
Well, I wanted to learn more. I've been 3D printing for about 5 years, and I wanted to build my own. Now I realize I should not have, because it was just such a huge time hole. But I mean, I got it done, so I'm glad, and it works really well. It's a really good printer.
Okay, so in terms of cost, I mean, I'm used to laser jets and inkjets, but what does a 3D printer cost in comparison?
Well, the price has gone down a lot. You can buy pretty cheap ones for around $300. And there are really, really expensive ones that cost like $200,000. Those ones print in metal.
Okay, now you mentioned that 3D technology was used in the Invisaligns, and we're seeing it used for surgery, head and neck malignancies, mandibular reconstruction, and I've got a photo of that, nasal reconstruction, cranioplasties. What other fields are they using this technology in?
Well, lots of different fields. I mean, there's a forum called Reddit/r/3D printing, and people are coming up with new and amazing ideas for how to use 3D printing every day. I'm just shocked every time I go on there by the incredible creativity that people have. One person, like his dog was paralyzed, and so he printed wheels for the dog but on his hind legs. Another person lost a finger, and so he 3D printed a new finger for himself. People are doing it in medicine. They're doing it in manufacturing. Houses are being 3D printed now.
Okay, now you have an interesting story to tell about 3D printing technology, and that's why I reached out to you. You had put a story on LinkedIn. Do you mind sharing that story with our audience?
I don't remember what the story is.
It's the one about the ring that you created.
Oh yeah, okay. So my girlfriend and I recently got engaged, and I had an idea. I wanted to design her ring using a 3D program and 3D print it. And I asked her if that was okay, and she said yes. So we went to Cartier, which is like the most expensive jewelry store ever, and we picked out a ring design that she liked. And it was simple enough that I could design it. That ring was $86,000. So of course we didn't buy it, but we took pictures all around it. And then I took those pictures home, and over the course of about a week, I designed something very similar to that ring in a 3D editing program. And then I sent that 3D design to a company called Shapeways that will print your objects in gold. And so I got it back, and it cost like $300 to make the ring. And she really loves it. And so I gave it to her. And now every time somebody compliments her ring, she tells the story that I designed it for her.
$86,000. And the base, you actually were able to do this for $350, and then you had to purchase a setting. Wow.
Yep.
So she has the show-stopping ring, and nobody.
Yeah. Yeah. Actually, I posted this online, and it got like 2 million views. A lot of people were really, oh my gosh, like a lot of people left some really negative comments about it, but most of the people were really nice.
Oh, come on. That's like brilliant.
Well, thank you.
So much
you.
for the double downers out there. That's pretty brilliant.
Yeah, I mean, like when you buy an engagement ring in the US, people say, oh, you know, it's supposed to be 3 months salary. It's supposed to be at least like $5,000. And I was like, no, I'm not going to do that. I'm going to make something.
Wow. And that's a story that she'll probably always tell, how amazing that is.
Yeah.
Okay. Well, so much for the double downers. Okay. I found an article that A. Pearson wrote. It was a piece about 4 years ago, and he listed disadvantages of 3D printing technology. So I'm going to go over some of those disadvantages with you. He said cost, but you said that cost has come down. As compared to injection molding, they consume 50 to 100 times more energy. The materials that it uses are limited. The printing, if it's an enclosed space, can generate potentially toxic emissions and carcinogenic particles. Too much reliance on plastic and job loss. Can you kind of talk me through what you think when you hear that term coming from a researcher?
I think everything he said is complete, except for the toxic fumes thing. That might be true. Usually you want to use it in a well-ventilated area. Some filaments have toxic fumes and some don't. So it's a good idea to look at the warnings. But the other things that he said, would you list them off for me? What was number one?
Yeah, it was the cost. And then he said it's 3D printers consume approximately 50 to 100 times more energy, and that there's limitations to the materials that are being used.
Okay, so as far as cost, I can build a prototype in 20 minutes and it'll cost me, 50 cents in filament. But if I wanted a factory to build a prototype for me, it would cost $500 to design the prototype and then $1,000 to print it, or to have them make an injection molded version of it, or more. It would cost me thousands of dollars to get a prototype of a product from a factory. Whereas with my 3D printer, I can print one for cents. So I don't really understand what he means by it being more expensive. Also, as far as, it using energy, I think he's talking about per part. So if I wanted to make 1 million parts, 3D printing would not be the best way to go about that. It would be less energy efficient than making a metal mold and injecting plastic into it. That's a very efficient process. But if you're making small batches, then you don't have to carve out a metal mold. You don't have to set up all the machines. You can just imagine something and then design it and print it out right there.
So there are certainly advantages. And of course, with every breakthrough technology, there's always this fear there's going to be job loss. But obviously, there are job opportunities in the field when this technology comes on board. So people have to learn kind of the shift. As we progress, people have to be able to make those shifts.
Yeah.
Okay. You know what? I'm going to give you the last word, because I think you always bring some innovative and interesting concepts to us. What can we anticipate with this 3D printing? And, should people be fearful of it, or should they embrace it? What do you think?
Thank you. Well, thank you, Dr. Michelle. I don't think there's any reason to be afraid of it. People were afraid of printed books. People were afraid of trains. So I don't like artificial intelligence. There's no reason to be afraid of it. Just learn about it, learn what it can do, learn what it cannot do. It's really fun. I love doing it. It's just a hobby. My 3D printer is the coolest thing I've ever owned in my life, because one time I had an invention idea, and then 3 hours later, I was holding it in my hands. That's, you can go from concept to an actual real object in an amazingly short amount of time. So what can we expect from 3D printing? I don't know. I think that the end goal is to be able to get rid of old manufacturing completely and be able to 3D print anything. And we can't do that right now. There are a limited number of manufacturing materials. It's mostly plastic or rubber. We can print on wood, or we can print with wood and ceramic and some kinds of metals, if your 3D printer is like one of those really expensive ones. But we can't make everything through 3D printing that we can already make with the other kinds of manufacturing.
Well, so Cartier is going to love you.
Oh my gosh. Yeah, they haven't sued me, which is great. But yeah, I think that is the end goal, to just have all manufacturing be done in a 3D printer way because it's very efficient.
Wow. Tyler, thank you so much for coming on Tap Talk. You're always such a breath of fresh air.
Oh,
and
thank you,
you
Dr.
know,
Michelle.
anytime I run across anything techie, I'm gonna have to reach out to you so you can keep us educated.
Yeah, for sure. I mean, there are some kind of tech charlatans. Like recently, a guy claimed that Google's AI is sentient. It's not. So if you have any questions, let me know.
I will. I definitely will. I think we gotta have you back to talk about that. I did read that. I was like, huh? I think he's on paid leave too.
Yeah, I saw an interview with the guy, and he does not know what he's talking about. He does not understand the math. He does not understand how AI works. So,
Tyler, you're going to be like famous one day. I just know it.
oh, thank you, Dr. Michelle. I appreciate that.
I'm waiting for that day. Okay, when you get back to your life, thank you very, very much for your time. I appreciate it.
Thank you, Dr. Michelle.
All right, too. Bye-bye.
3D printing is a French invention. It's possible to print tissue structures. You can wear 3D printed items. Did you know there's a 3D chocolate printer? The cost to produce 3D printed prosthetics will be 75% less. Now let's look at architectural and building applications for 3D printing technology.
It's no secret that building a house is expensive, and one of the most costly parts is the labor. What if, though, we could use technology to automate and make this process cheaper? That's exactly what Icon is doing with their 3D printed homes. They've figured out how to 3D print concrete walls and have already constructed a number of homes this way. Today, we're going to take a look at their latest and greatest luxury 3D printed house called House Zero.
My name is Dimitri Julius. I'm the Chief People Officer at Icon. And what you're looking at is House Zero, the first in our exploration series of homes. This is about 2,700 square foot house when you think about the 2,200 square foot main house and then the 350 square foot back house. We wanted to showcase what was truly possible with 3D printing and just at the edge of possible. And I think we pushed all the limits here.
You're probably wondering how this works and what exactly gets 3D printed. The 3D printer is shipped out and can be assembled by 4 people in an hour. Once assembled, it is able to lay layers of concrete to form walls that would typically take a whole crew of people to build. While someone does need to monitor the build, it's significantly less manual labor for this step of the home building process. The thing is, right now you can only really 3D print these walls, so you still need to pay for the labor of electrical, plumbing, cabinetry, and things like that. But this is a great first step in automating the home building process. Icon has already printed 7 affordable small homes for the chronically homeless in Austin, and 10 more in Mexico for families that did not have safe housing in the area. By automating building of the walls, they were able to build these homes much cheaper and faster than a traditional house, and in my opinion, they look much better than most low-income housing. For example, this is the tiny house village in LA that was constructed for the chronically homeless, and while it's better than nothing, it feels more like a shelter. Like, they kind of resemble more of a shed than a house. And these are the ones that Icon printed for the chronically homeless in Austin that just look much more like an actual home you would want to live in. And then they also built a neighborhood of 4 luxury townhouses in Austin where the first floor has concrete walls. All of these have already sold and now have people living in them. Now let's take a look inside House Zero, their latest luxury 3D printed house.
So I think the first thing you're going to notice actually before we even hit the door is there's not a single straight line along this entire linear run. We really wanted to use curvature and really have this architecture meet nature and head straight on in. So we're going to head on to the right and I'm going to take you into one of the main bedrooms.
So going down this hallway, you will notice a lot of cabinetry. Underneath is that cement wall. But it's cool that you can add wood paneling, tile, plaster, really anything you'd like over it. Here's a look at the first bedroom of this house.
It always gets asked, well, what if I want to put artwork on the wall? How does that work? So it performs just like masonry. This is our proprietary Lavacrete material, and you can just go get a tap screw from Home Depot and just plug that right on up in the wall. And so we've showcased that with art pieces kind of hung throughout. So very easy to do, not necessarily an issue.
Yeah, so you can still mount a TV, do all that.
Another thing that we wanted to make sure that we created was an option for maybe some optionality later on down the road. And so we chose this beautiful Douglas fir here on the interior of the wall. So if you decided 10 years from now you wanted to remodel, you absolutely have the options to do that as well, because those 3D printed wall segments are going to be standing for quite some time.
Over here, they've got a Jack and Jill bathroom with partial exposed concrete, but some of it is plastered over and the shower is tiled over. So you see the concrete as kind of a design element, but it's also very functional.
This is, this interior wall is a 3D printed piece that we just put some plaster and a rough trowel over to really showcase that there's different ways that you could finish this out. So all the traditional construction methods are still available to you. If you wanted to plaster, stucco, paint, or put siding over the house, you could absolutely do that. That would hurt our feelings, but you could do it for sure. Yeah, and so this is our office space. Again, if COVID has taught us nothing, it's that we really need to be thinking intuitively about how we utilize our spaces. And so this is fantastic for taking Zoom calls. Maybe it's a little office.
So again, here they left a bit of exposed concrete, but they did mostly wood paneled walls in this room, which definitely feels more familiar to a traditional house.
That's nice. So, I mean, it could be like a 3-bedroom house, but it's 2 mainly.
Absolutely, yeah. So you can, this is a flex space. You can utilize this however you want. You can pop a little nice bed in here, and then you've got, a nice additional space for guests.
And now heading into my favorite area, which is the living room.
For maybe some of the viewers out there, they might not know, but concrete itself is very thermally dense. And what that actually means is like it holds its own heat and temperature very well. So on like a 95-degree day in Texas with no central air on, it's gonna be about 75 degrees in this house with no air conditioning needed whatsoever.
I had no idea that it could actually do that.
The living room has a really cool feature that you can see from the outside. They have these 3 curved walls. They're really taking advantage of the fact that they can print things however they want with this.
So I really love this space because it kind of creates an open concept that I think we're all used to having. And so I like to chit chat, I like to hold court, and while I'm cooking, I would like to be able to, have friends or family at the dining room area. Also, there's some really unique moments where we didn't necessarily add additional space to the house, where we just thought about the active space and used it. So you've got, your little dining room area specifically. We've got a nice little cozy reading nook over here. There's an opportunity here to kind of have this office space that really doesn't feel like it's imposing on the house or taking away from. You can just come over here, maybe put on a nice record, put your earbuds in and get to work, or maybe just enjoy having a quiet moment.
I just love this built-in desk. I think it's super functional and it looks great.
It doesn't look out of place. Like sometimes having an office within a living room, it feels like you just didn't have anywhere else to put it, but this actually looks really nice. Like I would want it there.
So the kitchen, we're not really seeing 3D printed elements in this part of the house, but it is beautiful. I personally love this kitchen. But again, like you can't 3D print cabinets, at least yet. And then off the hallway of the living room is a powder room, which again, super cool how you can see that you can put different textures over the concrete and make it feel like a normal house.
You would have no idea that there is even the concrete behind it, so it can look like a totally normal house if you wanted to. I feel like people do like to add tile and different things in a bathroom in the kitchen, so you don't have to have the concrete design everywhere.
Just a little pieces of artwork that we did with the 3D printer to really showcase different flat things that you can do, all sorts of different angular design.
Then heading down the hallway is the primary bedroom and the largest bathroom in the house. And once again, they've done some really cool curves in the bathroom. In here, they've got plaster over the concrete and the curved wall in the shower that allows space for a bathtub as well. And it just is a really cool design element and makes it interesting, makes it feel really high end. And you can see here where the concrete meets the plaster, but it looks nice. This bedroom feels pretty similar to the first bedroom, but there's a few more windows. This room has probably the most exposed concrete of any room in the house.
One of the things that we really tried to do in this grand room was make sure that the space was about the space that you're going to use every day. So we borrowed some European design to really optimize using as little space as possible, but gaining as much storage as possible. So we thought that was pretty fun.
So I personally think the concrete looks really cool in here, but comment down below. I'm curious to know what you guys think.
And I think one of the coolest things about this space is the private little coffee nook. So outside this house, you've got a fun little kind of, we call it like just a coffee nook, a little breakfast area that kind of lives right here between the grand room and the 350 square foot ADU.
Now let's take a look inside the casita. They actually build these on their own as well, so you can get one for your backyard.
So I don't know about you, but this is my favorite space in the entire house. 350 square feet, and again, we kind of borrowed from that European model. So we've got this bed here that's actually a Murphy bed that kind of gently folds itself right back on into the wall.
I love that they added a Murphy bed in here, so this could be a guest room and an office, but it's really modern. The concrete looks great in here. I feel like anyone would love to have this in their backyard.
I mean, it's got all the different things that you would need for a lived-in space, right? We've got a little burner top, you've got your dishwasher, you've got a fully functional sink and refrigerator, and then you've got a fully functional bathroom, which I think is super cool. And this bathroom is just so rad.
It was a little tough to get a shot of this one, but it had that same plaster, curves, and a frosted glass window. Same style as the other ones, which I love. So that is Icon's House Zero. What do you guys think? Would you live in a 3D printed house? I think it's really cool because it's a step towards making the home building process more efficient and thus less expensive. And Icon's next step is building 100 3D printed homes in Austin. Thank you.